你知道全世界数学科普的顶流是谁吗？就是他，Grant Sanderson。不过他有另一个名字更为人熟知，那就是 Three Blue One Brown 三蓝一棕。从斯坦福毕业的他，在2015年开始科普视频创作，如今在油管上已经有超过700万粉丝。就在最近，他要加入我们的抖音了。那就趁着这个机会，我和 Grant Sanderson 进行了一场时间长达40-50分钟的谈话。在这段谈话中，我们交流了很多数学应该怎么样去学好，应该怎么样去理解数学的本质，他自己是怎么走上数学科普这条道路的，以及对于中国的学生学习数学有什么样的建议。其中的内容非常精彩，我们一起来看看吧。
I still cannot believe it's real because, all over the world, the math lovers, they all know 3 blue, 1 brown, and I cannot believe that I'm actually talking to you. Actually, once your voice sound arises, I feel like some function graphs and circles are popping out of my screen. Yeah,
Sure. Yeah.
yeah. So let's get started because, most people around the world know you through your videos, 3 blue, 1 brown. And your videos have really educated millions of people all over the world. Before 3 blue, 1 brown, there has never been such an influential channel. So I'm curious, and I guess many in the audience are also curious, what were the chances that you did all this and take it as a career?
It doesn't seem like the chances were high because it's not a thing I was planning on. As I was finishing college, I was messing around with just a personal coding project, which was centered around making math visualizations. I wasn't thinking about it as, and I will use this to make a YouTube channel, but I care about teaching a lot. I always have. And I think my ambitions at that point were, I knew I loved math. And so the main thing to do would be maybe pursue a PhD, become a mathematician. That would maybe be the way to let math be a complete part of my life. But I also followed various educational YouTube channels. I had some awareness that that was a thing, but I wasn't thinking of it as a career. But where some luck did arise was Khan Academy, which is an online educational platform. It was quite popular then, but it still is now. Had some open spots for fellowships where they would have people come in to make videos and articles for a year on various topics. I got into conversation with them. The very few videos I had made were helpful there. And that really opened my eyes, I think, to the idea that, hey, maybe I could carve out some kind of career path doing exposition online. And also, I just loved it. The coworkers I had there were great. It was really fulfilling through the day. I felt like I grew a lot in that time. And so I don't know if I necessarily would have continued with the channel if not for that opportunity. Maybe it would have continued as a side hobby, but that definitely accelerated the idea that, hey, maybe this is a place where I stand to add value, not through the traditional paths of academia, become a mathematician, but instead something more native to the internet. But who knows? It's so hard to speculate on different, parallel universes and the ways that they unfold.
Let's see. So what were the key factors that gave you confidence in this kind of unconventional career, like doing the mass communication content?
Well, so I can't say this was wise necessarily, but I do remember my younger self thinking I was hesitant about the future of like universities and academia as being a place of growth, because it feels like it's very oversaturated. You've got this dogma that like the way to succeed as like middle class is like make sure you go to college. It was kind of clear that maybe a lot of students out there don't really get value out of college. And just thinking, what will that system expand or will it just kind of stay stagnant in the next many decades? My younger self was kind of thinking, maybe it might just stay stagnant. I don't know if the like job opportunities for math professors is something that's necessarily going to grow. When I was thinking, like, I'm definitely optimistic that the internet grows in terms of usage on the internet. Now, that's a different thing from trying to carve a career path as an independent creator. But I think I'd seen enough to know that it just never hurts to have a personal project. And even if you don't make it into a career, writing on the internet or making things on the internet is undervalued. Like it doesn't have to translate to something that you're doing as a full-time job to still bring a ton of value. It might show future employers that you generate stuff, that you're the kind of person who likes to make things and you have a portfolio of the quality of things that you do make that they can then judge. I just knew that can't hurt. It's also fun. it wasn't so much strategic on like, I know for sure that like this is a path that will work out well.
Yeah, okay.
I think what I was thinking was, okay, I'll take like a gap year or two between undergrad and graduate school. I'll like start forging a little bit of a footpath here. And then maybe as I'm a PhD student or going to postdoc, and if I want to like write public books or like give talks or things like that, um, this can be something I can point to as a footprint on the internet. Not thinking, oh, this is itself self-sustaining, but hey, if I wanted to, write a book to the publisher, I could point to that as saying like, hey, here's evidence of the kinds of things that I write. Um, that felt more plausible to me.
Yeah, actually, this sounds quite similar. So for me, I'm also like at my second year of PhD, and I saw a video. I guess you may also have seen before is animation versus math.
Yeah.
And yes, by Alan Becker. It's really fascinating. So, but it's hard for most audience. They cannot understand what it is. So they ask someone to give a closer analysis. So I then decide to make some content. But at that time, I didn't expect to have millions of subscribers and then have this impact. It's quite similar. We noticed that you started this making math content dates back to 2015, and that is a decade ago. And just 1 year later, in 2016, you upload your videos firstly on Chinese platform Bilibili. I'm curious, and I guess Nina is also quite curious. Why do you come to Chinese TikTok Douyin again?
The nature of video online has changed. I think in the English speaking internet, for a while, YouTube was really the dominant platform. And then
Yes.
other platforms have started eking in into both in terms of short form and long forms. Since around like as we were approaching 2020, that kind of time, TikTok was of course quite dominant, and then various things like it, Reels and YouTube Shorts trying to compete. So the idea that there's just different places where people are to watch their content, that's more true now than it was then. You also see this in longer form where like podcasts might exist with a video form on Spotify as well as on YouTube and such. And so I think it doesn't hurt to just meet people where they are. Especially back in 2016, there was a certain culture around the nature of like community driven nature there. But
Yeah,
in the same way that uh, there might be people watching from like different countries around the world. It's like there might be people just on different like platforms, whether that's different video platforms in the English speaking internet or different platforms on the Chinese speaking internet. And it doesn't hurt to simply make the learning material available in more places.
I see. So you would like to catch up with this short form video trend and to meet up with more audiences.
Well, so I'll be honest with you. I don't love short
Uh,
form video for math exposition, or at the very least,
so
I
do
don't
I.
think it plays to my wheelhouse. I think it can be done very well, and I think there's people who do it very well. But the where I feel most comfortable, or where I feel I know how to add the most value, is more when there's like a long narrative or something where it's okay. Here's a really interesting piece of math. It's going to take some time to understand, but I promise it's going to be worth it if we like wrap our minds around it in the right way. And the path to get there can often be, 15, 25 minutes. I've found it very hard to find topics where you can go from the start to the end to really explain why it's true in just 3 minutes, say. I think it's very possible to elicit curiosity in 3 minutes. I think you can show something that's like, wow, this is genuinely interesting. Forget 60 seconds. I think you can do that, and it's a good writing exercise to do that. But the stuff where I think that like the animations lend themselves to really clarifying something as opposed to just like being a
Yeah,
flashy, interesting thing to look at. And my understanding is that Douyin is embracing long form content a little bit more, and it's not
I
necessarily
see.
purely short form in the way that maybe it was in its origins.
Yeah, I noticed you has created some short form videos on YouTube, which has never happened before. So, but as you said, you still will focus on the long form to be more clarified on some specific things to explain it more thoroughly. Is that it?
That's what I find the most fun. Yeah, I find that most
Yeah, yeah, yeah.
fulfilling.
So do I. So do I. So talking about these animations, I found maybe the most fascinating way of 3 Brown explaining things is that it often reveals some surprising connections, like Fourier transforms, linear
Mm.
algebra, and neural networks. So I think also as a video content creator, I'm curious, how do you choose topics that are both deep and accessible? These kind of topics is rare. Sometimes you can easily get running out of it. So what do you read or watch to stay inspired?
All sorts of things. I mean, there's no one answer there, but I think it's good to just regularly read like new textbooks in domains that I haven't necessarily studied before. Probably
Did
there's
you
more
regularly
material that
read
comes.
some new? Did you
Yeah,
regularly read new textbooks every month or every week?
not every week. No, God, it's so slow. Yeah, it's
Okay.
like they're not like normal books, right? I can spend like a week on one chapter, right? And I think that sometimes it's like you find the thing which is thought provoking, and then you got to kind of make it your own. You think about it, you noodle on it. It's not just like, you read line by line. The way I've been thinking about things lately is that there's like three broad categories of videos that I'll aim to make that are similar but have very distinct goals. So one will be if it's relevant to someone's course, usually a college course. And so you referenced
Yes.
like Fourier transforms or like linear algebra or calculus. These things, someone might be taking a course on that, and you can imagine they land on the video because they were searching for that. So that's one category. Another one would
Yeah.
be uh, something where it's sorry, there's a little bit of a loud noise outside. Hopefully that doesn't interrupt. But another one would be like clever proofs and really clever perspectives, where it's not so much that you're taking a course on it, but it's that, hey, here's this really beautiful idea. Maybe it was a proof, maybe it's a puzzle, and it's a solution to that puzzle. And you wouldn't search for it, but it stands to bring delight. And so competition math, that tends to have some of these. There's just certain like beautiful proofs. And then the third category is more like adjacent fields like science, computer science, where it's maybe a longer form, half documentary type thing explaining a thing someone may have heard about before, like neural networks, but trying
Yeah.
to dig in to say, okay, what's actually going on there and revealing the math within it. And those three categories, like the sources for where they'll come from are actually quite different. So the student focused ones and then the like more sciencey ones, usually I can just look to requests. Like, what if people asked, like, hey, would you make a video on X? Um, not 100% of the videos come from requests in that way, but it's a good source to know, hey, here's a thing people want to know about. I made Fourier transforms because people had asked to. I made neural networks because people had asked for that, all of that. The one where it's much harder to say, like, where does the content come from is on the clever proofs and just the beautiful ideas where there's just no one source. It's like conversations with people, like finding it in some little book, various things like that, that some random blog out there. It's just, there's lots of different things that might have the seed of an idea. And then also you do usually don't want to just regurgitate if the idea is 100% elsewhere, you're just like relaying it. I usually feel the most inspired if if there's at least some small way that I feel like I've made it my own, or where the visuals can make a meaningful difference on even how you understand it. There's a couple from topology that fit this category where I remember it's like this very short set of text inside a certain paper describing a topological proof, and it shows no pictures. I'm like, I wonder what that would actually look like. And like the act of showing what it looked like made me
Yeah, I
understand it
remember that
better.
video.
And so whenever that happens where like I don't know what it'll look like, but I know exactly how I would code it up, and then I code it up, I'm like, wow, that's what it looks like. Who knew? Like that's a feeling that makes me know, okay, this could be a good topic.
Yeah, that's what really math visualization is for. And I'm curious about like because the feedback can be quite random. Sometimes you spend weeks making a video that you like it very much. It happened to me, but it turns out the feedback is not as you expected. Did you ever get disappointed by this kind of feedback, like number of views?
Of course, yeah, I think it's impossible not to. I mean, you can say out loud all you want, like, oh, I don't really care about the views. That's not the metric of success. But yeah, of course, sometimes there's a feeling inside where you're like, man, I really thought that was going to be a very good one. And like, for whatever reason, it didn't
Yeah.
hit as much. Um, I did have recently on YouTube, what I really, really enjoyed making this video last year about holograms. And it was like a bit different and more sciencey. And uh, it was like a collaboration with a friend of mine. And I really enjoyed it. And I'm like, I think a lot of people would really like this. And it's not that it got a small number of views, but I remember initially when I put it out, it was a little more middling. And in my mind, I thought, I really thought this could appeal to more people than the usual audience space. Maybe I'm just wrong there.
Hmm.
A couple months in, I just did some like tests and iterations with what the thumbnail on it was, and like finding the right thumbnail ended up just like completely changing it to like be one of the more viewed, just most viewed
Sometimes
things
thumbnail
already.
is even more important than the content itself.
Yeah, well, but they have to have both, right? I think like a great thumbnail without the content to back it up, it just also won't hit. It's more like I felt like in this case I was like, yeah, it's good content. I know people would like it, but it was really hard to even convey what it was. Like the
Yeah, yeah,
topic of a
exactly.
hologram, it's hard to convey even in video what the feeling looks like to see one in person, much less with a still image. I'm like, how do I possibly communicate? Like, it's so mind-blowing if you can just like see what the thing is in person for the first time. I think it's similarly mind-blowing if you can see a video that kind of captures that. And I was like, I just can't even capture this in like a still image. And so it was kind of, I just knew like if I could
Yeah.
convey that sensation of the fact that it's mind-blowing somehow, like I'm like, I know it's possible to like convey what I want to convey here. I don't have like the design instincts to be able to do it in a still image, but it was like it felt like it was possible.
So let's talk more about the details of making a video. Like, I think the one thing that people may underestimate how difficult and how unbelievable it is for the 3B1 Brown videos is that the subtle balance between the aesthetics and the rigor. Because
Mm,
usually, if you want to explain really thoroughly and in rigor, then it will typically be quite tedious. You have to prove every step, prove every theorem, and that is, I think, is bad for math communication. But if you are too short, then as a hardcore math content creator, you feel something is missing. So how do you find the ideal balancing between that? Like which part of the detail need to be explained with good visualizations, but which part may be omitted?
You know the feeling when you're writing a proof yourself where like maybe there's a phase where you're like, I don't even know if I can prove this. Like I don't even believe that the fact is true myself, but maybe you're just trying various different logical connections to see if there's something there. And then there's another sensation when you say like, I really believe that this is true, or like here's the reason that I think this is true. And instead you're trying to like fill in the details to add the rigor. So I feel like for a public math exposition video, you want to get to the point where you're conveying like the meat of what the proof would be, like the core intuitions that will be that proof, and that someone who, you know, if it is a math student who's comfortable writing proofs, they would be able to fill in the details. Like you're showing what that main idea is. And then if it's not a math student, maybe they don't write as many proofs. They could still like believe kind of beyond reasonable doubt that whatever you're saying is true. That to me feels like what I'm trying to convey across. Like the goal is not going to be something that can be like immediately translated into lean and then compiled into like a verifiable proof.
Yeah.
But it like many proofs will have that sense of like here's what the big idea is or the intuition is. And I think proof writers have this as an instinct when sometimes you like stumble into something where you're like, oh, I've proven it, but I still don't really know why it's true, right? I think every like math student has had that experience. And then sometimes instead you say, here's the loose shape of like why I'm quite sure that it's true. How can I like translate that into some kind of some kind of argument. And so when there is that like when it feels like all you have to do is fill in the details, but like the big idea is there for the purposes of making the video, that feels like what I want to get at. And sometimes it still takes a lot to build up whatever that big idea is, right? It's not necessarily a quick
Yes,
thing to
right. Like the Groover
communicate, but
algorithm.
yeah, yeah.
You mean maybe just focus on the high level intuition and let people know what is the big picture of it?
And like, you know, as many details as you can give. Or sometimes there's things where the way that you would write it down in symbols is going to be certain like kind of dense and heavy, but you can just show what those symbols really mean without necessarily making it too formal, but still have the actual idea there. I mean, very often I think you can have something written in the language of like matrices and vectors conveying a certain idea. And if you just show like a vector and its transformation in some way, you can show what the same idea is. You're not removing any of the math, you're just showing it in a different language. But with the visuals available, you can kind of pack a lot in without having to overload someone's brain with the formalism of it. And it's like those
Yeah.
who are familiar with the formalism, they'd be able to translate it down just fine. And those who aren't, you're not really robbing them of all that much. I think a really great video as an example here, Vsauce, like 10 years ago, made one about the Borsuk Ulam theorem No, not the Borsuk-Ulam theorem. Well, the fact that you can divide a sphere into two, you can.
Tarski
Yes,
paradox, is it?
Tarski. Yeah. So he did one on that, and I think it captured like all of the spirit of the rigorous aspects of the proof. There wasn't any substantive idea that it skipped over, but it was entirely spoken in plain language and just visuals. And so I think it did a really good job. It never used the phrase like group generators or things like that, or like the free group with two generators or something. But it showed the underlying substance of what that idea would be and how it was relevant to, dividing up a sphere. And I thought it was just a perfect example of how to do real math in a way that is as publicly accessible as possible. And so very often it's not choosing which details to skip, but instead, how do you translate those details into a language which says pretty much the same thing? I mean, you wouldn't be able to formalize it into lean as readily, but it says pretty much the same thing. But it's more universally understandable what you're trying to say. And sometimes also there are facts, like let's say we're talking about geometry related things. You might have a proof of something that's meant for arbitrarily high dimensions, or you're like, here's a fact about spheres in even dimensions. And if you just show it in like 2 dimensions or just show it in 3 dimensions, okay, you're not showing it in all the dimensions, but maybe you're still getting across what the substance of the proof would be in all those cases, but you're not taking on the challenge of trying to get people to somehow visualize like a higher dimensional thing. I think that can be fine. Like I made an entire linear algebra series where most of the time was just focused on very concrete like 2 or 3 dimensional vector spaces, and in some sense, that's robbing people of the generality of linear algebra, not necessarily just being about like the physical space that they embody. But the hope is that you get a really, really solid understanding in that concrete setting, and then it's just not that much of a leap for a student to know how the same facts translate to other settings. And I tried to do this in the last video to kind of like convey what that generality would be. But I think really, really making sure that it's solidly understood at one concrete case gives you 90% of the effort that you need.
I cannot agree more on this point. Like the Hawking said, uh, every time when you add one more formula to your book, your readers cut by half. Yeah, I think this is also true for math communication videos. And it's really about how you translate those intimidating formulas, the lemma's theorems, into something that is visualizable and understandable by some people with the minimum requirement of the math content language. So yeah, so can you walk us through about how you design a single video from initial concept to the final animation? How do you decide which part is visualizable?
Yeah, so there's not a universal answer here, but I'll take a recent example where like I'm slowly but steadily making a thing about Laplace transforms. And for that one, it's
Mm.
like, okay, the reason to make it was because a lot of people have requested it. So it's like, where did the idea come from? People asked for it. Okay, so then what's the angle on it? I tried to read around a lot the way that different disciplines talk about it. Like the way electrical engineers talk about it is actually quite different from the way that pure math people talk about it. I tried to, I just was noodling in like a notebook for a long time on what are the different ways that you might motivate where this thing comes from, what it's trying to do. And I wouldn't actually make the visual at that point, but I would have a pretty clear sense of like what it would look like just by like doing the theory of it and like, okay, I know what I would code up here. And after feeling like, okay, here's a motivation such that once I'm like stepping through what this thing is, it's not just like a random set of symbols, but someone could maybe understand what we're trying to do. As soon as I feel like that is there, that seems like a good core to it. And then sitting down to actually make the visuals, usually like by that time, it's like I've sort of imagined what they will be, or at least I've imagined what I will code up and then see what will be what pops up after I encode it. In this case, it's kind of like I know what it will look like just because like the theory is more straightforward. There's other things like I don't know, fractals or something where you know what the code would be, but you don't actually know what the end result will look like. And then the I go back and forth. Sometimes I will write out the script exactly and then kind of sentence by sentence animate through it. Other times I'll just give a loose outline and then make the animations as if I was preparing a talk and then speak over it extemporaneously rather than worrying about like the sentence level articulation. Because like when you're just looking at the visual, it's like you and the viewer are both looking at it at the same time and you're kind of talking through it. For some things, that's a little bit more straightforward. Now, this project has ended up taking a long time because there's like a lot that I wanted to say, or I decided that actually making an entire thing to set up the prerequisites for it would be a valuable addition to like a differential equation series. So this is a very common thing that happens. I start to make a video and then it just multiplies. I'm like, oh, actually, rather than this one video, somehow there's like three on the docket. And sometimes I then rein it in and I say, no, I actually don't need those ones. So let's just make one concentrated video. In this case, I think my plan will be that I just actually make the three that I have in mind because it's a big topic and I would like to fit it into a differential equation series. So that is a long one. There's other quicker ones where when it is in that category that's just a clever proof, those are so quick. I love to make those because actually it's like I just have to say, what is the aha moment that I'm going for? What's the puzzle statement, right? Like, okay, do I need to motivate the puzzle statement or can I just go right in? So it's like, what's the puzzle statement? How do I motivate it? And then you like drawing the line between the statement of the puzzle and then whatever the aha moment is. It's a little bit of a writing exercise, but it's pretty straightforward usually. And so I'll just like write it down, usually in text as a script. And then I might have a notebook with like some loose sense of what the imagery might be. But I'm usually like, as I'm writing, I'm just like imagining what will be on screen as I write it and then
Same
kind of
here.
fill it in there.
Yeah. Do you have some like plans for also making some new things and new possibilities to 3 Brown's future videos? Maybe try some new content topics or something.
I mean, certainly. I mean, it depends on what you mean by how new, but I think
Hmm.
not in the immediate future,
Maybe,
but in the longer term future, more things that involve like interviews with other mathematicians or experts and kind of centering it on there. Like a piece I did recently with the Terence Tao was actually quite fun in that way, where it's
yeah.
kind of someone else's core ideas and then like helping to bring them to life. I think that was quite nice. Uh, there will be probably a piece about like a kind of documentary on the role of AI in math research sometime later this year that will be a pretty different style. And that, it's the thing I'm happy to experiment with. I think one thing I would love to do, I started going down this road in 2022 and then kind of putting the project on a shelf, but I'd love to take it off the shelf, is like a very like hand-drawn animated uh, story around a particular piece of math history, and really getting this piece of math history out. And that would be quite different from the usual channel energy, but I think it would appeal to the same audience. So there's definitely things like that. But it takes anything that's new takes quite a bit longer because you're still figuring out exactly what you want it to be. And I also think if it's a completely fresh channel, you can just kind of try stuff and it's okay if it's bad and you're just trying stuff. But then if it's a channel that has an established, I don't know, audience or an established reputation, it feels a little bit harder to just like throw out stuff that may or may not be good. Like I feel more compelled to really try to make sure that it's good before it goes out. Um, so it
I
becomes
I
harder.
feel that
Yeah.
pressure. I'm really, really excited. I cannot wait to see these new videos. So hope you can come out this video soon. And also, as a Chinese native math communication channel, I may receive some comments and messages that you may not come across frequently. And for example, due to excessively heavy burden of passing Chinese National College entrance exam,
Hmm.
many Chinese students excel in solving particular math problems, but struggle into understanding this deep conceptual knowledge for calculus, probability theory, or something. So, what advice would you give to the educators and these students who really want to know why, but not just passing the exams?
I do think sometimes if you take a thing which a lot of people have memorized or have learned by rote, and then you just show it from a completely different angle, or you kind of show how would you have rediscovered this, or what is it really saying, sometimes that seems to really motivate people. Um, I feel like the best answer would be showing why they should care, like how this sort of question would arise in science rather than just on a test. But it's I've noticed it's just bizarrely effective to simply take a thing that they have seen, but then show what it's really saying. So as an example, one of the linear algebra videos I made, way back when, like 2016 or so, was about the determinant of a matrix and what the determinant of a matrix means. And if you think of matrices very visually as like transforming space rather than just as a grid of numbers, there's a very, very visceral meaning to the determinant. It's telling you how much things expand or contract.
Yes.
And most students don't know this, and they will say they haven't seen it, or like their textbooks didn't mention it, or their professor didn't say it. And maybe that's true. I think most textbooks probably do say it, but if you're just not showing things very visually, it'll go in one ear and out the other. If it just says like, oh, the determinant tells you the scale by which volumes change, you're like, whatever. I don't even know the way that it's related to volumes. Like that sentence makes no sense. But if you're showing it very, very literally on the screen, then it has a way of landing. And there's so many comments on that video that are people that are like grateful for the explanation and then mad at their like class or their textbook or
Yeah,
previous.
same here.
They're basically like, why didn't anyone tell me that this is what it was? And so I think that is like a common enough emotion for the test-oriented students, where you say, here's the thing that you just had to have hammered into you, but here's what's really going on. I don't know, maybe another example. Like the quadratic formula is something that a lot of people have to memorize, and it's just like this like pile of things. And I think there's some pretty beautiful ways to think about quadratics and just why they would naturally arise, and like how you're arriving at the solution, and how if you don't memorize it, you don't have to memorize it. Like just ways that you can sort of rediscover it. I haven't made any content on that, but I think there's a lot of potential to basically step back and say, hey, here's what's really going on there. Here's how to think about it without ever memorizing anything. I think people can feel satisfied by that, even when you're not even showing the connection to science or the connection to how it comes up pragmatically. Now, of course, that will be the best way. I mean, I have multiple friends from Silicon Valley who didn't love math growing up, but ended up, they would really, really like trigonometry, or they would find themselves really engaged on topics related to like sines, cosines, and tangents. And the reason is because they were into video game development, and they would notice in game development, like all the time, you'd have these expressions like sine, cosine, tangent come up. And so they had a need to know what those things meant. And, trigonometry is not exactly the most engaging subject if you're not already into math. It's not like the class that most people would find like, this was the really inspiring one. But the fact that they were laser focused on that one in particular because they had this external need tells you that, hey, the real way to get people into it is to make sure that they have a real need to know it. That's not because they're studying for their college entrance exams, but it's because it speaks to a passion that they do have. Now, that's very actionable advice if you're a private tutor and you know the student particularly well and you know what they like. That's very hard advice to act on if it's just a general content creator, because it's like, of the millions of students who might watch this, you don't know what their specific interests are. Like you kind of can't tailor it in quite the same way. So that's maybe why the more generic, like here's just a visual way to understand what it's saying, not necessarily tied to an application. Maybe that's why those work counterintuitively well. But if you can find a super generic application that is equally inspiring to everyone, that's probably the better way to do it.
So I feel like the most valuable part about the Cerebral One Brown's video is really precious compensate resources with respect to the lectures, and you really convey this vision that can make this like determinant, singular values, eigenvalues alive. And I think this is what I'm also working on. So
Nice.
really happy that we can have the Cerebral One more here. They call you like teacher grant, something like this in
Well, and
China.
thank you for doing everything that you do as well, and like making like the more people there are out there who are trying to help clarify these things and do it in different ways with different personalities. I think that really adds a lot, and it really helps so many students.
And maybe this is the final question. So many Chinese students have a very structured path laid out for them. For those who would like to explore mathematics beyond their curriculum, even the parents and the schools, they are very focused on the practical outcomes like college admissions, jobs, something like this. And someone who loves math but feels pressure to study something more useful. And even me, I feel the pressure from my parents saying that you're just doing videos, you're not doing the real job, something like this. So what would you like to say to these young Chinese students who dream of blending art, technology, and math, or taking the unconventional path?
I think recognizing it doesn't have to be a career to still be fulfilling. Like finding the ways that engaging with it in a different way, like as a hobby, can still bring a lot of value to life. And so I almost think viewing math, if you're a student, this means viewing certain kinds of math as like an extracurricular activity in the same way that you might play a sport that's outside of school, having a type of math that you engage with where, okay, it's not the school math, but it's like when I was younger, I would just spend a bunch of time with like books and notebooks doing things completely unrelated to school. I just liked it. It was just my hobby. And I think the thing that I would really enjoy was trying to feel like I could have invented it myself in some way. Right. And that would be really slow. Like I would just go really, really slowly through a particular idea. But I didn't have to go fast because it wasn't like there was a test that I was studying for or something there. It was purely done in the same way that a kid might like shoot basketball hoops in their backyard uh, to like spend their afternoon time. And I think making room for math in that way is very worthy. And this can also translate to what it's like in adulthood. Like let's say you do have a career path which is more practical. One, that's actually great. Like I don't even think all the math savvy people should become pure academic mathematicians. That's probably not the world we want to live in. Like we need a few, but we don't need that many. And so taking all the people who are really good problem solvers and having them off in a lot of useful disciplines and applying those problem solving instincts elsewhere, that just seems very good. You can still just do math as a hobby and you can find groups of people with like-minded interests in the same way maybe there's a book club, right? You can have like just a group of people kind of
Yeah.
doing math with each other and it takes the stress off of it and it doesn't have to be that like you can I think it's just very nice to spend like a whole week on like a single equation sometimes or like really taking your time on making a certain topic your own. And so relieving all of those other pressures and letting it serve the same role in your life that art and hobbies and sports would, I think that's healthy. And I would encourage more people to do that.
Okay. Okay. Thank you. So that's word. And at last, uh, please let me, behalf of the Chinese audience, to welcome Grant Sampson and 3 Blue 1 Brown to Chinese TikTok doing again. Thank you very
Thank you
much.
so much.